In this lecture, we are going to discuss few problems on operational amplifier. Before going to take few problems, just briefly I want to discuss the concept of op-amp and the required concept that will be used to solve the problems only. Okay. So here, 1 minute. So operational amplifier, you know that it is a high gain differential amplifier, and this is the symbol we are using. And this I will call it V minus, and this is V plus, and this is output V naught. And if gain is AD, then V naught will be simply, okay. So this gain is very high, thus it is generally not useful for normal operation in open loop condition, because quickly it will go to saturation level. Okay. So if we want to use this op-amp as an amplifier, then we need to use negative feedback. This is important. And how to provide negative feedback? Just with this op-amp, so this is inverting, it is non-inverting terminal. So if we provide one element between output and inverting terminal, this element, if I call it RF, that means we are providing one negative feedback to this op-amp. Okay. So this is the important thing. The output is fed back to the input side, especially it is connected to inverting terminal, then it is a negative feedback, and we can have some other circuitry here and here, other side. But this is the main important concept. This RF is called feedback element. So negative feedback should be there if we want to use this op-amp as normal amplifier. Okay. So two type of amplifiers we will discuss here. One is inverting type amplifier, that you know. So in this case, this negative and positive, so feedback is always there. Okay. And this end is grounded. This is your VI. This one is R1, suppose it is RF. So this output easily we can calculate. So one more important thing in op-amp we need to consider, that input impedance or input resistance Ri is very large. So if input resistance is very large, what is the meaning is that this current is 0 ampere and this is also 0 ampere. No current will enter to the device because of high input resistance. Okay. And output resistance is close to 0. For ideal op-amp. Okay. Now just briefly I am discussing. Now whenever there is a negative feedback, one more important thing is that these two terminal, this V minus and V plus, they are almost becoming same. That is called virtually connected, because we are assuming that with this negative feedback V naught is finite. Okay. So what is V plus minus V minus? This difference is nothing but V naught upon AD. And if AD is very large, like 10 to the power 6, one example of AD could be 10 to the power 6, and V naught is suppose 10 volt. In that case, this voltage is in the microvolt range, and that is almost equals to 0. So meaning is that B plus is almost equals to B minus. That is most important part. It is called virtually connected. We will be using these two concepts. So this two, if it is 0 potential, this is also 0 potential. Then whatever current is coming here, that same current is flowing through this side, because no current is entering to the op-amp. Using this concept, what you can find? We can find out output voltage, that is nothing but minus RF by R1 times VI. I hope you know these things. I am not going to discuss this one. Second one is non-inverting. In non-inverting, what is this? The input is applied to non-inverting terminal. So here input is applied, but this side the feedback will be there. This is your RF, this is your R1, this is grounded, this is V0. So expression for V0 is 1 plus RF by R1. This is the gain multiplied by VI. Okay. So with this concept we will start and we will try to solve few problems. This is very easy. I am telling you that we can solve lots of problems and very quickly if you can use proper method to solve these problems. Okay. Now this is the first problem. So can you solve this problem? So this is two sources are given. One is 12 volt, other one is 22 volt. One is connected to this point here, another one is non-inverting terminal. We need to find out V0 and I0. Okay. So can you solve this thing? Can you find what is the V0 and this I0 given in the figure? So anyone can solve it? So how to solve this one? It's very easy problem. One easy problem I have considered first. Then we will be considering more difficult problems. Okay. So as we are having two sources, one is 12 volt, other one is 2 volt, we can use superposition principle. So simply, if whenever you will be getting more than one source in a circuit, linear circuit, you can use superposition principle. So what is this? So in this principle, one source will be considered at a time, and we will consider that the source is acting alone, and other sources we have to remove it. If it is voltage source, it is shorted. If it is current source, it is open circuit. That's simple. Okay. Now if I consider this 12 volt source is acting alone. Okay. So what circuit we can consider? It is minus, it is plus. This is the circuit. You can see that at this end, this is a 12 volt connected. Is it okay? And there is a feedback here. So this is your 8 kilo ohm. This is your 4 kilo ohm. Okay. And now what I will do, this end, this 2 volt source, I will make it grounded, shorted. Okay, because we are considering 12 volt source at a time. Okay, and you can see that one load is connected 20k. Now one important thing is that in op-amp, if op-amp is ideal, if nothing is said, you will assume that op-amp is ideal. Ideal means the gain is infinite and input impedance is infinite and output impedance is 0. So these three things you will consider. Okay, if nothing is mentioned about the operational amplifier, you will assume that it is an ideal one. Okay, so if the output resistance is 0, So you will see that whenever you will connect a load, it doesn't matter. The output voltage will not depend on this load resistance. Okay, so this one we can ignore. So if we consider 20k, 10k, 5k, doesn't matter. We will be getting the same output voltage V0. Okay, so for this, this circuit is simply an inverting type amplifier. I'll call it this output voltage V01. So what is V01? It's simply its gain is minus RF by R1. So RF is in this case 8 and this one is 4. So minus 8 by 4. This is the gain multiplied by supply voltage, that is a 12 volt. Is it okay? So this is 2. It's a minus 24. Okay. So V01 is minus 24 volt. Now consider the second one. Second one is meaning is that we are considering 2 volt source is acting alone. The 12 volt source we need to make it sorted to ground. So okay. So what is the circuit? This circuit is very simple. This is the resistance. This one is there. This is V0. This is your 4K. This is what 8K. Okay. Here the input voltage is, so be careful here. With respect to ground, this node potential is not 2 volts because this is plus sign, this is minus sign given. Okay, don't make mistake here. So this node potential will be minus 2 volt with respect to ground. Okay, so be careful at this end. And 12 volt source I have omitted, removed. So this I have made it grounded. So this circuit, and this circuit is very simple. It is okay. The load is connected. I said that it doesn't matter whatever load you will connect it. So output voltage will remain same. So this time I will call it V02. So what is the V02? So this circuit is simply non-inverting amplifier. So you need to identify the type of the amplifier, then quickly you can solve it. So what is the gain for this non-inverting amplifier? 1 plus RF by R1. RF is 8 and R1 is 4. This is the gain multiplied by supply voltage is your minus 2 volt. Okay, so this is 2. So 2 plus 1 is 3. 3 into 2 is 6. So it is minus 6 volt. Is correct? Yeah, your answer is correct. So what is the V0? Overall V0? That is the V01 plus V02. Okay. So that will be your minus 24 and this is your minus 6. Total is minus 30 volt. Right. And what is the current I0? Can you find the current I0? That's shown in the figure. Anybody? Can you find I0 current? How to find I0? I0 is the current through this one. This is the current. So what is the node potential here? This is your, what is the node potential? So this potential and this potential will be same. It is your minus 2 volt. Is it okay? And this potential, overall potential, you can find out. What is this one? It is minus 30 volt. Okay. So you can consider this potential is minus 2 volt. This potential is yes, is it coming 3.5 milliampere? Is it minus 2 plus this one is minus 30, so it is plus 30, it is by 8, that is milliampere. Am I correct? It is 28 by 8. So this is your 7 and it is 2. So it is your 3.5 exactly milliampere. Yeah, it's good. So I think this problem is very simple. Yeah, you can quickly solve it. Fine. So can you take the next problem? This problem, in this problem you need to solve these two things, V0 and what is your V0, and again what is the current I0. Right? So again very similar thing. So only thing is that now here with one independent voltage source we are also having one independent current source, and both are connected to inverting terminal directly or indirectly. So this problem is simple. Other end non-inverting terminal is grounded, so we can find out this V0 very easily. Okay, so again you can use superposition principle because we are having two sources, 12 volt and 2 milliampere sources. So if we are having 12 volt source one at a time, so what is the circuit? Can you read out the circuit? That is very simple. We'll draw in the similar manner. This is minus, this is plus, this end is grounded. Okay, this end is there. So we'll remove this current source. Current source we'll remove it, means open circuit. We'll disconnect the 2 ampere current source and we'll keep on this 12 volt source only. Okay, this is your 4K and this feedback resistance is there, that is your 3K. So what is a V0? That I will call it V01. So V01 is very simple. How much it is? Minus 3 by 4, this is the gain, multiplied by the voltage. The supply voltage is 12. So I think it is minus 9 volt. Is it okay? So now consider the second one. The 2 milliampere current source is acting alone. Yes, probably your answer is correct, minus 15 volt, good, too good. So 2 milliampere current source, now we are considering. Okay, so what is circuit? Circuit is like this. This is minus, this is plus, this end is grounded. Here the current source is there, that is your 2 milliampere. This resistance is there, but this source is not there, I have made shorted. So 12 volt source we have grounded. So this is your 4K. And now from here there is a feedback. This feedback is 3K. So what is the output? That I will call it V02. Now here important concept is that as there is a negative feedback through this 3k ohm, so obviously output is finite, that we are assuming. And if your output is finite, these two end potentials are becoming same. So if it is 0 volt, this is also 0 volt, right? And if this is 0 volt, this is also 0 volt. So these two gap, there is no gap at all. This end is 0 volt, this is 0 volt. So there is no potential gap between across this 4k ohm. So there is no current through this one. This is 0 ampere. Okay, no current is flowing through this 4k. So that I can disconnect. I can consider that it is not connected at all. And again you can see that no current is entering this side. This is also 0 ampere. So what is the meaning? This 2 milliampere source will go through this side. So this side is also 2 milliampere. Yeah, yes Raj, I think yeah, whatever you have done, it's perfectly correct. You can also convert this voltage source to current source, and then current source you can combine, then again you can convert it to voltage source, or rather you can use Thevenin equivalent circuit, that also could be done. Okay, so this is also that thing also I can use. Okay, I will discuss this point. It's a good method. Okay, right now I am discussing very simply. We have two sources, we can use superposition principle. That is also not very tough. Very quickly we can solve it. Okay, so now we are considering this thing. 2 milliampere is flowing through this 3k. So this is 0. So what is the potential gap? V02. So you can see that current through 3k is 2 milliampere. Okay, so what is the equation here? So this is 0. This is V02, so current is 0 minus V02 upon 3k. Okay, I am not writing 3 into 10 to the power 10, and that is also already given 2 milliampere, so I am writing it is 2 only. I think you understand. So here it is 10 to the power 3, here 10 to the power minus 3, that will cancel. Okay, I hope it is correct. Because current through this 3k ohm, this end is 0, this end is V02, so gap is 0 minus V02, and resistance by resistance is 3k, that will give you 2 milliampere. Okay, so what is the result? V02 is nothing but minus 6 volt. Okay, so what is your V0? So you can see that V0 is very easy to find out. So V01 plus V02. So this is a minus 9, it is a minus 6, it is minus 15 volt. This is absolutely correct. Now can you find I0? What is I0? The I0, that is the current entering to the op-amp from in the output terminal. Can we find I0? Anyone got the answer for this I0? Now you can see that whatever current is coming here, okay, and also it is coming from this side, that will go through this path. So I0 will be addition of these two current. One is coming from this end to through 3k ohm, and one is through 6 kilo ohms. Okay, yes. So how to find out these things? I0. So this I0 is addition of two currents. So this is your 0 and this is a V0. I have got it. So 0 minus V0 the current through 3K, so by 3, that is in milliampere, plus again this end is 0, this is again V naught, so 0 minus V naught by 6K, that is in milliampere. Okay, so what is this? So minus, I think you can combine, so how much you are getting? Minus V naught, you can combine, this 1 by 3 plus 1 by 6, okay, I think it is minus V naught by 2, and that is minus, so minus minus it's plus, so it is, now it is 15 by 2, that means 7.5 milliampere. It should be in milliampere. It's a positive, remember, this minus minus getting cancelled, now it is becoming positive. It's good. So it's 7.5 milliampere. Okay, fine. So can I take, okay, so this is also important, thus I want to, so just this one, the same problem we can solve it. So this is a problem. So using another method, without using this superposition principle, we can also solve it. So how to solve this one? So we can go for this way. At this end, this left hand side, this total network, we can replace by Thevenin equivalent circuit, or by source conversion you can simplify it. Any way you can do these things. So this is our network. I think Thevenin network will be much easier compared to source conversion. Source conversion also you can do it. So 12 volt, and this is your 4K, and this is your 2 milliampere. So this node, suppose it is A and A prime. Can I find one equivalent circuit, one Thevenin voltage and one Thevenin resistance between these two nodes, A and A prime? So what is the VTH? Who can find out? So in our previous lecture we have discussed so many problems on Thevenin circuit. So what is the VTH here? And what is the RTH here? And how quickly you can solve it? Anybody? Can you please find VTH is 20 volt? Okay, I need to solve it. Yeah, it will be 20 volt, correct. And RTH is 4K, absolutely correct. So what is this VTH? VTH is nothing but open circuit voltage. So if you keep this part open, so this part at this point VOC is nothing but VTH. So if we keep this part open, then you can see that the current, this 2 ampere current is going through this side. It has to go through because this side is open. I have made it open. If I keep it open, then whatever VOC is there, that is same as VTH. Is it right? So we are going to find the VTH. So what we will do? So this is circuit. So I'll keep everything 12 volt, this is 4K, and this is 2 milliampere, but this part I have made it open. So the current flowing through this one has to go through this side. So what is the drop across these things? 4K. So current through the 4K is again 2 milliampere. So this drop is nothing but, if I call this V1, so V1 is simply this current 2 milliampere 10 to the power minus 3 and 4K resistance 4 into 20 power 3. So this 20 power 3 minus 3 cancel out. So this is your 8 volt. So you will get 8 volt drop across this 4K. So what is the open circuit voltage then? Then what is the open circuit voltage VOC? So that will be this potential 12 volt plus this potential V1. So VOC is nothing but this 12 volt plus voltage across this 4K, because we will be considering clockwise manner, minus plus, again minus plus, additive. So this 12 plus 8 total is 20 volt. So VTH is your 20 volt. And what is RTH? RTH is very simple. So you remove, so this is the resistance. We will remove this current source, we will make it open, and we remove this voltage source, shorted. So this is your 4K, and you look from this side, this terminal A prime. So what is the equivalent resistance? So I have only one resistance, 4K. So this is your 4K. Okay. So now thing is very simple. We can replace this network by this one 20 volt source and 4 kilo ohm resistance. Then it will become simply inverting type amplifier. Can you identify these things? So what is this problem now? This is minus, this is plus. This is your inverting amplifier, 3K, and this one we have replaced one resistance and one voltage source. This voltage source is 20 volt, this resistance is 4K. This end is grounded. Okay, we can get one load, that doesn't matter. Okay. So it's simply inverting type amplifier. So what is the output? So this output is simply minus RF by R1 minus 3 by 4. This is the gain, multiplied by supply voltage, that is a 20. Okay. So 4, 5 is a 20. So this is your minus 15 volt. The same thing we have got it. So you can use opposite principle, you can use Thevenin, you can use source conversion, whatever it is. Okay, in many ways you can solve the problems. Good, very good. Next one. The third problem. So can you solve this problem? Anyone can try. This is a good problem. Okay. So this is, we are having two operational amplifiers. So this circuit is similar to one important concept that you may know or may not know. Right now I will not discuss in detail. That is called instrumentation amplifier. That I will be discussing later, but without that concept we can solve it very quickly. So how to solve this thing? Any idea? Now slowly we'll move. Okay. So what is the potential here? What is the potential at this node? I think it is very simple. That is your 5.8 volt. So obviously it is a 5.8 volt. Am I correct? Now can you tell me what is the potential here? Can you find the potential at this node? Who can tell me? The potential at this node. What is this one? Yes, so 2 volt is added with this one. So 5.8 plus 2, it is 7.8. Good. Next, my question is that what is the potential here? Can you find the potential here? Okay, at this node that where I am these things, suppose if I give the name, this is suppose A, this is B. At V node, what is the potential? So what is VA and VB? These two. Anyone can tell me what is the potential VA and what is the potential VB? Any idea? Okay, let me explain these things. So this 6 ohm resistance is connected here, but you understand that it is connected to non-invert terminal. There is no current flow here. This is 0 ampere. So no voltage drop across the 6 ohm resistance, 6K. So this potential is also same as 7.8 volt. We are assuming that op-amp is ideal. Okay. And there is a negative feedback here through this path. As there is a negative feedback, so we can expect that output is finite. And if output is finite, these two potential, this potential and this potential, that they will be same. So this potential is again 7.8 volt. Again it is connected to inverting terminal. There is no current flow this side. This is also 0 ampere because of high input resistance. So this potential and this potential will remain same. So VA will be same as 7.8 volt. So it doesn't matter whatever resistance is connected there. So potential will remain same 7.8 volt. I am assuming that operational amplifier is ideal one. Okay. Very similarly, this potential is also 5.8. This is also 5.8. So this is also 5.8 volt. And if it is 5.8 volt, at this point also you will be getting 5.8 volt. Yes. Now question is that, can you find out the current to this 4K ohm? This current is suppose I am considering. Is it okay? So can you find I? Okay, so what is the current I? I is simply VA minus VB by this 4K, that is a milliampere. So this gap is 2 volt because 7.8 and 5.8 it's 2 volt, and by 2, yeah, this is equal to 0.5 milliampere, correct. So if this I is 0.5 milliampere, now next question, if I consider this node is A prime, this node is B prime, okay, can you find the gap VA prime minus VB prime? So if I understand the gap between these two, then easily I will be able to find out I naught. Because what is I naught? I naught is nothing but BA prime minus BB prime, this gap, by 4. This one. That milliampere. But who can find VA prime minus VB prime? Anybody can try? So what is circuit? You can see that this is 0 ampere, so I can consider this is disconnected. No current is flowing through this side as well. This is also 0 ampere. This is also disconnected. So basically these three resistances are connected in series. Am I correct? This end is B prime, this end I have considered A prime, this end is A, and this is your B. This is your 4K, this one is 8K, and this is your 8K again. Okay, so you can see that there is no current is entering this side. This side current is 0 ampere, this side also 0 ampere. So we will not discuss. The same current is flowing through this side, and that is your I, 0.5 milliampere. How it is 11.8 volt, the gap? VA prime, okay. VA prime only you have calculated. That could be. But exactly VA prime is not required. If we can understand the gap between these two, it is sufficient for us for this problem, because we need to calculate I naught. I naught depend on the voltage gap across this 4K, that is VA prime minus VB prime, right? VA prime you have got it 11.8, VB prime is 1.8, so I think gap is 10 volt. So I think it's correct. Will be also getting 10 volt, because VA prime and VB prime will be the I into R, no? So this is the gap, the current is I, what is the resistance? So this I times R, what is the resistance R? So I is your 0.5 and R is your total resistance, 8 plus 4 plus 8. Is it okay? That's very simple. So it is 0.5 multiplied by, it is 16 plus 4 is 20, and that is equals to 10 volt. Correct? So 10 volt is a gap between these two nodes, A prime and B prime. So now easily we can find out I naught. What is this? This gap is 10. And this is your 4, so 10 by 4 equals to 2.5 milliampere. Is it correct? Are you enjoying this problem? So this problem is little bit complicated, it looks complicated, But once you will get the idea, the thing is very simple. Okay. So let me consider the next problem. So do you have any doubt? Anything? No? Okay. Let us consider this problem. Can you find V naught? For this circuit. So fourth problem we are discussing. Okay. Can you identify this circuit? Anyone? So what is this one? So this block, this is interesting, this is minus, this is plus, and you can see that this inverting terminal is directly connected to output side. Okay, this is your output V naught, and input could be applied to this non-inverting terminal, that is your VI. So this circuit is very easy to analyze because there is a feedback. Whenever there is a feedback, I have said that these two potential will be virtually connected. So this potential is also VI, and this end and output is also connected, so output is also VI. Is it correct? So input is VI, output is also VI. So what is again? So what is the voltage gain? V naught by Vi will be Vi by Vi, and that is equals to 1. So gain is 1, means unity. Okay. But this circuit is having input resistance Ri is infinite, because no current to enter, no current can go through this side. So resistance is infinity. So this device will have input resistance infinity. So Ri is infinite. And output resistance, if you look from this side, this is called output resistance R naught. R naught is again ideal op-amp, is going to be 0. So this is one device which will offer voltage gain 1, input resistance infinity, output resistance 0. This combination is called voltage buffer. So this voltage buffer circuit we can use to isolate two stages. Okay, but again we can connect these things without any loading effect. Suppose here we have one network, you can see that left hand side we are having one network and right hand side we have another network. If I connect these two directly, there will be some loading effect. Means what is the meaning is that whatever potential you will calculate just considering this circuit, that will not remain same at this end if op-amp is not there. But the beauty is here is that here this op-amp will isolate these two network. So meaning this left hand side it is completely independent, and right hand side it will get this potential and then it will work. Okay, I hope it is clear. So in my previous lecture videos I have discussed this thing in detail. So if you have some confusion you can go through. Now we want to solve this problem very easily. So what I am saying that, so this voltage buffer will just connect these two nodes without making any loading effect. Meaning is that, so as there is no current is entering this side, so this circuit is complete. Now we can find out VA. So can you find VA? Who can find VA? Anybody? If anybody is there, please try to give an answer for these things. What is the potential across at the node A? Meaning is that potential across 8 kilo ohm. Can you find the potential across this 8 kilo ohm? VA is simply potential divider circuit. Can you use it? So this is your 8K, it's a potential divider circuit. So it is 8 upon total. Total is your 4 plus 8. Okay, multiplied by supply voltage, that is your 18 volt. So we can find out the potential at this node. Okay, so this is exactly you are correct. This is not 18, it is a minus 18 volt. Okay. Is it fine? So the value is 8 by 12 into minus 18. So this is 2, this is 3, I think it is 6, yeah, it is minus 12 volt. Perfect. So be careful about sign, because this potential is your minus 18 volt. Okay, absolutely correct. Now can we find out V naught? So what is VB? So VB is same as VA, because I have said that this output is same as these things, because it is a voltage buffer. So that is also minus 12 volt. So if this potential is again minus 12 volt, now we can find out again V naught. It's a potential divider circuit. So what is V naught? Again one more potential divider circuit. Same thing, 8 upon 8 plus 4 times this one minus 12 volt. Okay. So what is the value? So I think it is 12, 12 will cancel out. This is minus 8. So minus 8 volt. Am I correct? Good. So V naught is minus 8 volt. Very nice thing. Okay. I hope you have got this point. Now we will consider one more problem. So this is the problem. Can you solve it? So what is the V naught and I naught? So it is a similar one. I hope you can do it. So what is the important thing? This left hand side, you can simplify it by Thevenin equivalent circuit, and then you can replace it. Okay. Or just we can make it much more easier. We can simplify this network first. We can take equivalent, Thevenin equivalent for this network, then we can connect it. It will also work. Okay, quickly we will get it. So what is the value? Can you find out? So this is your operational amplifier. This end is grounded. This end is 6K. Here it is 6K. Okay, and this load is also given 6K, but doesn't matter. They about the voltage level, but obviously current will be different. Okay, so now this network blue one. So can I simplify? So this network, this is 6K, this is 6K, this one is 12 volt. Can I find one Thevenin voltage? And one Thevenin resistance. What is this? So it is open circuit voltage equally divided. So across 6K you will be getting half of that. Okay, so it is your 6 volt. And 6K and 6K parallelly connected, so its equivalent will be half of that, so it is 3K. Am I fine? So that thing I can include here. So I have this network. This is your 6 volt and this is your 3K. Okay. Now it's become very simple. So these two we can combine. Total is 9K. Both are in series. It is a 9K. So that is nothing but your R1. And your RF is these things, 6K. So it's an inverting amplifier. So output voltage V0 will be minus RF by R1. So 6 by 9. This is the gain multiplied by this supply voltage 6. Exactly, you are correct. 636 minus 36 by 9 is a minus 4 volt. Perfect. So I naught, very similarly you can connect this thing. So this current, whatever current is coming, this whatever current is coming, and it will go to this side. So this I naught will be again 0 minus V0 by 6 plus this side current again 0 minus V0 by 6. So 2 times of V0 by 6 means minus V0 by 3. So it is exactly 4 by 3 milliampere. Correct. Good, very good. So this is the next problem. Can you quickly solve this problem? So in this problem, what is your I naught? and what is your V naught. Again, anyone can find the I naught? This is a very simple problem. So here thing is that there is no current is flowing to this side. This is 0 ampere. Okay, that means I naught, the same current is flowing to this side. So this is one circuit, closed path. Same current is flowing here. So 5 volt source is there, 20k is there, 10k is there. So easily you can find out the current. So what is the current? Current is simply 5 upon total resistance. That is your 20 plus 10, 30. That is your milliampere. Am I correct? Is it fine? So this is 5, and this potential we can find out, but thing is that this supply voltage will provide certain current I naught, same current will flow to this side. So I can consider 20 and 10k, they are in series. So 5 upon 30 means 1 upon 6 milliampere. Okay. Now what is V naught? So before that, what is this potential V plus? So if we can find out this potential, then rest circuit, this circuit is simply non-inverting amplifier. Okay. So I need to find out V plus. V plus also, now we can find out these things. Or another way, it is 5 by 30, 1 by 6. So this potential will be, it is 0, so this gap, V plus is nothing but the voltage across 10 ohm resistance. So 10 into 1 by 6. Exactly. So it is your 5 by 3 volt. Good. So once V plus is known, now easily you can use V naught. So what is the V naught? So for that circuit, it is, this one is R1. So this is your R1, this is your RF. So 1 plus RF by R1 is the gain into supply voltage, that is your V plus, the node potential at the non-inverting terminal. So this is 1 plus RF, RF is 20 and it is 10 multiplied by V plus is 5 by 3. So I think it is becoming, you to cancel out, it is 3, it is 5 by 3, yeah, exactly correct, it is a 5 volt. Good. So you can see that op-amp problems are not very difficult. Once you can understand the strategy, then you can easily solve it. Okay. Now next problem, can you solve this one? Okay, you can take this problem. This is little bit difficult, but how to tackle these things? So first, can you find out VA, the node here, node potential here? Then you will try to find out V naught here. Okay. Can I find these things? What is VA? And then you can find out V naught. Any idea? What is VA? So you can see that there is a negative feedback, but not using only one resistance. Rather, you have one network here. It looks like a T network. Can you identify? This is one branch, this is another branch, this is one branch. So you have T network that is connected here instead of one single resistance that will provide you negative feedback. But anyway, this is connected to negative side, negative potential, negative terminal or inverting terminal. Thus, it is complete. So you are getting one negative feedback. Because of that, you can assume that the output voltage will be finite. Yes, that is the question. How to find the RF in this circuit? So two ways you can do these things. So what you can do, this T network you can convert to pi network or start to delta conversions. That is one way to possible. Okay. Another one, without considering this thing also, you can find out. Now you can see that if this one is perfectly connected to ground, so this is 0 volt, right? If this is 0 volt, this end is also 0 volt. Okay, we are assuming that negative feedback is there. Then whatever current is coming here, that is going through this side. Means again the same negative feedback concept that we have got. But earlier it was connected to exactly output terminal. So this end was connected to output terminal of this op-amp. But right now it is not at this end, but it is connected to other terminal. It is fine. But whatever current is coming here, same is flowing through this side. So this potential will be similar to earlier, minus RF by R1. Can you check this thing? Because this potential is Vi minus 0 by R1, and if I consider this is RF, then 0 minus Va upon RF, so you will be getting Va equals to minus RF by R1 times these things. Am I clear? So you can see this thing. So what I am saying that this end is Vi, this is R1, okay? So I can consider 2.25 the volt minus 0 by 20k the current I. This is same as 0 minus Va upon 40. Am I correct? So what is Va? Va is minus, so this cancel out, it is 2, so 2 times of these things, minus 2 times of 2.25 means minus 4.5 volt. So your total output voltage you are telling minus 8.5 volt. How it is? Let us find out. So VA, is it correct? VA is minus 4.5 volt. Everybody? Is correct? And any doubt till now? I hope it is clear. No? Just we have considered the VA part. So VA value we have computed. Now next task is to compute V naught. So what will be your V naught? Let us find out. So this V naught, I can take simply KCL here. It will become very simple things. Okay, because this current to this side, plus current to this side, that will be equal to 0. So can I apply a KCL here? That is your VA. So this side current is VA minus 0 by 40. Okay, so this is a milliampere I am considering. Okay, always. Yes, you can find out the 8K, the current through 8K, then you can solve this problem. That also fine. Otherwise, so that also I will discuss. So if you use this KCL only, so this is the current to this side, this is your VA minus 0 upon 10 plus this is your VA minus V naught upon 8. Okay, and that will be equal to 0. Is it fine? So if you simplify this thing, how much you are getting? Total LCM is 40. This is your VA. This is your 4 VA. And this is your 5 VA. And this is your minus 5 V naught. That is equal to 0. Am I correct? That implies that 10 VA equals to 5 V naught. So 2 I can cancel out. So what is the V naught? V naught is 2 VA. Is it okay? And what is your current? What is the current through 8 kilo ohm? That you can calculate. So in this case, the 2 times minus 4.5, so we are getting minus 9 volt. But you are getting 8 minus 8.5 volt. How? Is it clear? So different way also you can calculate that what he is saying that. So what is the current through this 8 kilo ohms? This is of I1. What is that? So if this current is I, so this current will be, so this is 4K, this you can see this is ground, this also ground, this is also 0 volt, this is VA. So basically this 40K and 10K, they are connected parallelly, same node potential across them, no? So 0 to VA, it's also 0 to VA. So if current through this 40K is I, so 10K will be 4 times, because resistance is 4 times less, so current will be 4 times more here. You will get more current. So here you will get 4I. Is it okay? So this current will be 4I. So what is I1? I1 will be, this current is I, this is 4I, so total will be 5I. Okay. So what is the I1 current? You can easily find out this one. So you can see that I1 is simply 5I, and I already we have got it. This is our I. Okay. So this is your 2.25 by 20 times 5. This much current you will be getting. Okay. So then you can find out this potential. So what is the voltage drop across this one, and what is the potential drop across this one? You can find out, and that will be your total V0 voltage. Okay. So V0 will be 0 minus this drop will be V0. Okay. So be careful to write this thing. V0 will be 0 minus potential drop across the resistance, that is I into 40, and minus the potential drop across 8 kilo ohms minus I1 times 8. I hope you will be getting the same results. Okay. So because this I1 is 5I, can I replace I1 equal to 5I? So this is a minus 40I, and this is also minus 40I. Total is minus 80I. And I is, so minus 80, and I is this thing 2.25 by 20. So this is 4 times. So 4 times of 2.25 is minus 9 volt. Is it clear to all of you? So any doubt? So this is an interesting problem. Please take care how to handle this one. You can also solve this problem using start to delta conversion, but that I am not doing. Okay, I can give you some hints how to use it. Okay, just see this one. So this circuit could be solved using the start to delta conversion. So this network we can convert it to, so our aim is to replace this star network by a pi network. What is the pi network? This is the pi network. So as it is grounded, this is also ground, this is ground. So these are the nodes. You can find out these 3 resistances: R1, R2, R3. Okay, I hope you know how to calculate this R1, R2, R3. That I am not going to discuss here. Okay, now if you connect the rest circuit, the rest circuit is here. This is minus plus, this is grounded. This is your 20K. This is supply voltage 2.25 volt. Okay, now this end only it is connected here. It is this side, and this side is connected to the output end. Then this output is again connected to 20K load. right? Now here how to solve it? Once you will get R1, R2, R3. So I think that one, so one asks this thing, what is RF? Now you can see in this point. So this R1, so what is the current through R1? This potential is also zero potential, because if it is zero potential, it's zero potential. So this is also zero potential. This is also zero potential. So no current will go through R1. So this is your 0 ampere. Means you can disconnect it. Okay. Now this R3 is connected to output side. So instead of this one, I can connect it here. This is your R3. Same thing. And already I have said that if you have defined load, it does not matter. If op-amp is ideal, you will be getting the same output voltage. So output voltage does not depend on all those things. So what is left? Input side 20K, this is your R1 equal to 20K, and this is your RF. RF equals to simple R2. Okay. So what is the output voltage? So it is now simply inverting amplifier. The gain is RF, means here R2 by R1 is 20K. So R2 should be in the kilo ohm, okay, into supply voltage. Supply voltage is 2.25. Just calculate R2, you plug in there. I hope you will be getting the same results. Okay. Any doubt? So first find out R2, R1, R2, R3. So just now we need R2 only. Is it fine? Is it okay? So just the next problem I can show you. In this problem, can you find out this 3, 1, BA, VV and VC? This circuit is little bit complicated, not that much complicated. You can easily find out VV looking at this one. Anyone can say these things. What is VV? Anyone can tell me what is VV? Okay. So I am waiting for your response. So can you find out the value VB at least very quickly? That could be done in a second. Yes, what is value for VB? Okay, I am not getting any response. So anyway, so this problem I am giving to you. Please solve it. And find the solution for VA, VB and VC. And if you get these things, please share your answer in the comment section. Okay. Let me know that okay, you can solve this problem. It's not very difficult. So once I'll giving you some hints. Once you will get VB, then use this network. This is your simply inverting amplifier. So you can relate VA and VC by minus RF by R1, that gain factors. So VA and VC will be related. Then you can take KCL at this node. You can find the value for VA. And once you will get VA, so relation is there VC, so VC also you can get it quickly. So this problem is not very difficult to solve. Please solve it and let me know your answer in the comment section. Okay. So thank you. So we'll discuss more problem in another video. I think it is more than 1.5 hours. I should stop here. Thank you.